Okay, so we'll now talk about how you can do implementation for the event-driven design in Java, and then we'll speak about how you can do it in iPhone. However, both implementations actually follow the same pattern. Let me talk about the pattern first before we actually dive into the Java code for this video. If you recall this diagram over here, when we talk about event-driven design, that's kind of like a design sketch. So you got multiple subjects on the one side, and also over here, you got multiple subjects, you got the intermediate events, and also you got multiple observers over here. So that's a completely general runtime scenario that we have to deal with, which cannot be done elegantly using an observer pattern. So now, for both the Java and iPhone version, we're going to have three modules. So modularity is actually applied over here for the good design. We're going to have three modules over here. So module number one, we're going to have this part here, the intermediate part about the events. So this will be something that most of you haven't seen before. So that's why it's really important to get this part right. So this will be the module for events. So you can think about this is the module. So here I try to use the term module because in case you're not really using OOP for your design purpose, in that case, module might correspond to maybe a file or maybe simply just a module keyword in your language. But if you're programming in OOP, in that case, it would be a class. So the module will be for an events. Okay, so that will be eventually turned into iPhone class or Java class. So that'll be the first component that we'll talk about. And then we got the other we got the two sides of the components. So one would be the subjects. So this will be the second component that we'll speak about for both implementation. So this part here is the subjects. So there's another module over here, which is the subjects. And the third one is about the multiple observers on the other side. So that would be the third one, the third module that we'll talk about. So you want to have a very clear separation of concerns over here about the three modules that we're going to speak about. So this will be the module for observers. And sometimes we call them listener. For those of you who may be taking or have taken the user interface course, in the course over there, whenever you talk about event-driven programming, so that's kind of similar to the idea about event-driven design that we are talking about, even though we are not really using any GUI library for this Java implementation part. Okay, so you may call it listener as well. Okay, so these are the three components you want to keep in mind, and then I'll try to refer back to this general structure over here when I'm going over the code. So we only got three classes to worry about, and then we have a small test to actually show you how you can put all the pieces of the puzzle together. Okay, so let's go back to the slides. And the first class we're going to look at will be the events in the middle, the event class. So this will be the most important data structure for you to understand. You can think about, in some way, the event is kind of similar, not exactly identical to, but similar to the subject class when we talk about the observer pattern. So here, rather than storing just a list of observers, we're going to store their objects plus like a pointers to their functions. Okay, so these are the two things. So we're simply using a hash table over here to store all the we call the listeners or observers. So the keys for the hash table will be just the objects for the observer themselves, and then every time given an object for the observer like identity, we're going to map into the pointer to method that we want to retrieve in order for execution. Okay, and then we got event constructor, and now we simply create an empty list of observers or empty list of listeners. Okay, and then we have subscribe over here. Subscribe means every time when we first create an observer or listener, we are going to pass their identity, and also we want to retrieve their action as well in order to subscribe. But this will be actually from the observer side. We'll see exactly how we can retrieve the action as a method handle, which is a library class in Java, right? You can look up the API for method handle later, but I just want to go over the code to see how things can be done. Okay, from the event side, it's very easy because you're simply given these two argument inputs. So what you will do is you'll simply extend the hash table accordingly, right? By passing the identity for the listener and also the pointer to the action. Think about the action is something that's actually stored over here for delay execution. So the action will be, for example, to update the temperature or to update the humidity and etc. And then over here we got publish. So that's kind of the other side for the subject, right? So every time when the subjects, when they say, now I'm going to update the temperature, for example, in that case, I want to publish the updated temperature value into the relevant events. When I update the humidity value, I'm going to publish the updated value to just the humidity, right? So it depends on which value you're really updating. So when we do publish, so now we have to go over publish is a little bit similar to the notify that you learned in the design number 2. However, notice that we are not really explicitly calling the observer anymore. We're only calling the store function pointers that we actually when they first subscribe. So that's kind of the difference you may want to contrast yourself once when you are studying the two patterns. So we'll simply go over all the listener's actions rather than just listener, right? Just listener action. And then for each one of them, we'll simply just retrieve the action. So we can simply say listener action. Remember, it's a hash table. So we can simply pass the identity for each listener, right? It's like objects. Remember, when we first subscribe, it's going to be the object, right? And then we're going to do simply say action, which is of type method handle. Again, that's a library class you can look up. An action that invoke with arguments, so we simply say this will be the context objects. You can think about what we're doing is we're saying listener dot action with the arguments. That's basically what we're doing. But somehow, because those actions are stored for delay execution, so when you retrieve them, you cannot say listener dot action with arguments anymore. So that's why you had to say action and then call the relevant library method and then with the context objects and argument instead, right? That's kind of the trade-off you have to give in. Okay, and then that's basically about subscribe and publish. So what we have just talked about were these two methods over here. So we talk about how you can do subscribe over here and how you can do publish. So these are the two methods that we just talked about in the event class, in the event module. Let's go back here, and these are just the two notes which I just mentioned. You can study them. Basically, I already mentioned them. Okay, let's move on to the second class for the weather data. So now we're basically talking about this side. We talk about the subjects over here. So for the subjects, we basically just have to know what data might be observed, what data might be monitored, and also we want to see, we want to declare the events over there. So where you actually declare the events, after all, you have to declare each event as a variable. But where do you declare them? We have choices here. We definitely wouldn't declare events in the observer themselves. It doesn't really make logical sense. We may declare all the events in the subjects. That kind of makes sense. However, you may also choose maybe to have maybe a separate module over here, simply called the event collectors, and then put all the events over here. That's another design you may want to do. But for this illustration, I will put all the events as static variables in the subject class, meaning that the events do not really depend on individual instances of the subjects. It's simply just like a placeholder, just put them there. Okay, let's go back there, and then let's see the weather data, the subjects. So again, we got all the relevant information here, all the monitor variables. We got temperature, we got pressure, we got humidity. And when you actually construct the weather data, just the same as before, like design number 1, design number 2. And then we simply set the measurements over here. Okay, and notice that in Java, you cannot really easily write class invariant anymore, right? But we'll see that when you actually move on to the IFO design. You can always put the contracts over there. Okay, so now we got, as I mentioned, we're going to get 3 events. One event will correspond to the temperature. You can see change on temperature, right? We'll simply just initialize this event. Remember, initially, when you first construct the events, it's going to have an empty list or empty table of the listeners. And then we got change on humidity. Basically, is the events that correspond to humidity over here. We also got change on pressure, which is the event corresponding to the pressure variable over here, right? So each variable has its corresponding events. That's kind of the key mapping you want to have. And then we say set measurements is a mutator method that we talked about before. And now it is now very important. For set measurement, that means there's some updates that's really happening over here. So after we have set the temperature, humidity, and pressure locally on the subjects, now we have to publish. So remember the conceptual sketch I did previously when I talked about the design. So now every time if there's any publish action that's occurring to the events, we have to somehow to say now, since the events, this particular value has been updated, so the relevant events should really reflect this updates back to all the subscribed observer accordingly, right? So this is how we do it, okay? So the idea would be, since the change on temperature actually simply store a list of actions over here conceptually, right? It's actually a hash table, but it's basically a list of actions. So now for each of the action that were initially stored for delayed execution, now will be the time to invoke them. Okay, so let's see how we can do it. Okay, we'll simply just say publish, right? We already defined how you can do the delay to execute those store function pointers in the publish. You can look up the definition for publish later yourself. But I'm going to put everything together after I go over all the classes with you. So change on temperature is one event. So now we're just being a little bit pessimistic. So we don't, well, sometimes maybe the new value for T, H, and P wouldn't really modify the current value. Maybe the value stay the same, but it's okay. We just publish anyway. You can fine tune the performance over here if you wish. So now we say for the temperature events, we're going to publish the latest value for temperature. Okay. So now let me say one thing here. The temperature over here, let me say right away. The temperature over here really corresponds to the arguments over here, right? That's, as I said, the latest value that we want to publish. Okay. Okay, and then we can also publish for humidity, so you can see the context object is different. So now it's the change on humidity events. We can also publish the latest pressure value where the context object is the change on pressure, right? So far, it's not really too complicated as long as you have this conceptual map in your mind. So we have talked about this already. We have talked about this. So now let's talk about this. The main complexity for defining an observer is how do we retrieve from individual update. For example, if there's an updates method over here, how do we actually retrieve the star, the pointer to updates? So you will need some library method for you to do this, which is a method handle. I'm going to show you. Let's go back here, and then let's go to current conditions. So that's one of the one kind of observer. I'll just show you for the current conditions for statistics and also for the other one, well, basically you got three kinds of app, right? You can each one of them should be done in a similar way, right? So now for current conditions, you got temperature, you got humidity. So these are the only two measures that we are interested in the context of current conditions. We know that already from the previous design. Okay, and then we have the update method. So think about, eventually we're going to store a pointer for this method to the event side whenever we subscribe. Just keep that in mind. So we have update temperature, which in which case implementation is pretty easy. Notice that we have parameter list, which is with just one parameter of type double, and the return type is simply just void. It's a mutator. And also we got update humidity defined in a similar way. So now we got current conditions. How do we initialize the app, the observer? We'll simply, okay, first of all, we're using a lookup. The lookup here is simply a utility for us to really retrieve the method. I'm just using it. Should you memorize the line? No, you don't have to. Later on, if you want to do event-driven design in either Java or in other OOP, this might be something similar to what you have to do. So you will just have to look up the corresponding library methods or classes in that particular OOP. I'm just trying to show you some idea. So the lookup is basically something that will be useful for retrieving the method pointer. And let's try that. So this UT here stands for update temperature. Okay, so that's the first pointer to method that we're going to retrieve. So we simply use the lookup that we actually get before. So lookup would be the utility for us to find. So it's simply just called find virtual. So that's kind of for us to retrieve the pointer of the method. So now, in order to really retrieve that method handle, so what do we need to pass? We need to pass several information. Number one, the context class. You may have seen this expression over here in your previous 2030. Think about this one here, get class. It will simply just tell you what's the context class. For example, the context class is, in this case, would just be current conditions. Okay. And the second information will be what will be the name of the method. So once you know where the context class is, you want to know which method, for example, update temperature that you want to look for. What about the next one? Well, you want to know about also what's the return type and what's the parameter type, right? In that case, you'll simply do this interesting expression over here, but again, you don't memorize it. You just get a reference point, you know where to go to. But you should really understand what's going on over here. So we say method type, and then we'll say this will be the return type, which is void. In case you actually, if the update method were like an update accessor, in that case, it might return something that's not void. In that case, you will do something else. But typically, update method should just remain to be returning void. And then, so this will be the parameter list. So now in this case, we only got one parameter. You can see over here, update temperature only got one parameter over here, just double. That's why we say double.class, right? So that's about how you can retrieve the update temperature. You can think about what this will do is, it's going to retrieve all the necessary information for storing the pointer to this particular method for delayed execution. Later on, whenever the subjects actually publish any updates, okay, later on, so we're going to store basically this method handle into the events when we do subscribe. And later on, so you can think about the UT actually will be stored over here, the update temperature method handle. Later on, if there's any subject that publish any updates over here, we're going to just invoke this particular update temperature method handle. Okay, that's what we're going to do. On the other hand, contrast with what happened in the second design for the observer design pattern. In the observer design pattern, if there's any updates from the subject, right? Actually, there's no intermediate events in the second design. Whenever there's any updates from the subjects, what we will do is we have to say whatever observer that is in the list, we're going to say the updates. So this is actually fundamentally very different. You can think about this one here. You have to still get access to this particular observer and then call their updates. On the other hand, in the event-driven design, somehow the updates handle, or UT, right? Update handle conceptually is a pointer to method. This one has been stored, so you can invoke that right away. You don't really have to go all the way back, at least not directly. Okay, so that's kind of I'm pretty sure that the event-driven design idea is very new to you, but it's something very common and also very elegant about designing for the general scenario. So you will have to learn about this. Okay, let's go back here. That's how we retrieve the method handle for update temperature. We just do the same for update humidity, right? So I'll just show okay, sorry. Before we actually move on to the next one, we have to subscribe. So you can see weather data is a subject. Remember, it's a static attributes for change on temperature, right? That's the events. And for event, we can subscribe. So what do we subscribe? First of all, we want to subscribe the context objects. So later on, when we want to invoke this UT over here, we want to know what's the context. It's also almost as if we say this.ut. It's a very, very informal understanding about this, but it's not precise. Okay, so that's about this part here for the update handle. Okay, so basically this subscribe over here is going to store, basically whenever you do subscribe, it's going to store the UT as one of the possible action that event has to keep track of, just one. Okay, so that's about for the update temperature handle. We do something similar to the update humidity, right? So this one here is going to store the method handle for update humidity because we got two update methods for this particular app. Okay, this particular observer. You do basically the same, get class, and so now the method name is different, update humidity as opposed to update temperature. And also now for the method method signature, so now it will be void and also the same, right? You can see update humidity returns void, and also the argument or parameter is simply just double. This part is the same, but in general, it does not have to be the same. And then we subscribe it. You can think about we are subscribing to a different event. Notice that you can see this one here. We are subscribing to the temperature events by adding UT update temperature to it. On the other hand, when we subscribe to the change humidity events, we are adding the update humidity to it, right? It's different. Okay? Notice the subtlety over here. Okay, so after this, we may want to display. So now, locally, we are guaranteed every time, at any moments, whenever we want to display, we don't need that explicit first step as we did in the design number 1 anymore. Because guarantee every time when there's any updates from the subjects, the event is guaranteed to run all the store method handles and execute the updates back to the every one of the relevant subscribers. So in this case, every time when the subscriber wants to display, it's guaranteed their local copies over there is up to date. It's guaranteed. Okay. So now we can simply just say temperature and humidity and print them out. Okay, so that's about the other 3 classes that we spoke about. So we spoke about, again, this class, events, this class over here for subjects, and this class over here for observer. So now let's take a look at, back to the slides, let's take a look at this small test over here to see how everything can be put together in the runtime execution.